everybody. I thought I'll just do a couple of questions for you on standing waves. So it's these ones. And the first question says, draw the shape and state the wavelength of the following waves. And it's got the first overtone in a closed pipe, the second overtone in an open pipe, and second overtone in a string. The lengths of all these pipes and strings are given. What we need to remember is that the fundamental in a closed pipe is only quarter a wavelength, so it's got shape like that. So the first overtone, which is the third harmonics, will have 3/4 wavelengths. So what does that shape look like? So 3/4 wavelengths look like that. And then we've given the speed of sound has been given in your question as 330 meters per second, and if we have to calculate the wavelength, we don't need the speed, we just need 3/4 wavelengths is equal to 1 meter. So a wavelength is 1 times 4 divided by 3, so that's about 4 divided by 3. If you take your calculator and you just go 4 divided by 3, you get 1.3 meters. Okay, the second overtone in an open pipe, 4 meters long. The second overtone is also the third harmonic, but in an open pipe, the fundamental is half a wavelength. So the third harmonic is 3 half wavelengths is the length of the pipe. So a wavelength is 2 times the length of the pipe is 4 divided by 3, which is 4 twos are 8 divided by 3. You get 8 divided by 3 is 2.7 meters. So the length is 2.7 meters. What does it look like? So your 3 half wavelengths in an open pipe is drawn as 2 halves and 2 quarters. So that's a quarter, it's a half, another half, quarter. That's what it looks like. Similarly, for a string, the third overtone is again the second overtone is again the third harmonic. So you've got 3 half wavelengths. Your 3 half wavelengths is 1.2 meters. So your 3 half wavelengths is 1.2 meters. So your wavelength is 2 times 1.2 divided by 3, which is 2.4 over 3. That is 0.60 meters. No, 0.80 meters, sorry. Okay, so that's the first question. I'll also do the second question with you, which says a rod. So I'll just wrap this off. Okay, a rod which is 200 centimeters long is clamped 50 centimeters from one end, leaving both ends free, and it's set to longitudinal vibration. So this is your rod. It's 200 centimeters, so halfway is 100, quarter of that, so it's clamped over here. This distance is 50 centimeters. The whole thing is 200 centimeters. Question A, what type of point, that's node or antinode, will there be at the clamp? The clamp doesn't vibrate, so you have to have a node at the clamped end, so that becomes a node. If that's a node, the open end always has to be an antinode. Okay, so then is what type of point will be there at each end? So the open end is an antinode, that is also an antinode. So, and then draw the longest wave which could be set up. Now the distance from one antinode to the node, which is quarter a wavelength, is 50 centimeters. So after another 50 centimeters, you have to have an antinode. And after another 50, you have to have a node, because they're at equal intervals. So there's going to be a node over there and a node over there. So what's the shape of the wave going to look like? So it's symmetrical. So you've got an antinode, node, There's an antinode, node goes through, then antinode. So that's the shape of the wave. And what's the wavelength of this wave? If you look at it, this is actually a whole wavelength. This is a quarter and that's a quarter, so that's half a wave, and that's another half. So you get a whole wavelength. So the wavelength is actually 200 centimeters, which is the length of the pipe. Okay, so hope that makes sense. And then question 3 is a tuning fork has a frequency of 160 hertz. And it says calculate the wavelength of the sound it creates. So wavelength V is equal to F lambda, or wavelength is V over F. So you just go 330, which is given over here, the speed of sound in air at the top, divided by 160, and you get your answer in meters, which is the wavelength. You can put that in your calculator and get the answer. And then it says, oh, we do have to calculate it because in order to answer the next question, so I just go 330 divided by 160, 2.06 is the wavelength. And then the next question says, calculate the shortest length of a closed pipe and an open pipe in which it will resonate. So a closed pipe, the shortest length is the one that will take the fundamental frequency. So the fundamental is quarter a wavelength. Okay, so you get quarter a wavelength is the length of the pipe, but the wavelength itself is 2.06. So what's the length of the pipe? It's 2.06 divided by 4 will give you the length. So that is 2.06 divided by 4 is 0.52 meters. Now, if instead of a closed pipe, you had an open pipe, now in an open pipe, so next part, your fundamental is half a wavelength. Okay, so what's the length of the pipe? Your length of the pipe that contains half a wavelength, so your length is half wavelength. The wavelength is 2.06, so the length of the pipe is 1.03 meters. Hope you can see that. Oh, so you couldn't see that on the camera, but that is how you do that one. So bye for now.